Greetings, everyone. This is our webinar, Concrete Ways to Improve Vessel Operational Efficiency with Data. 3 use cases from our sponsors, maritime data integration and management company, Opsealog. Our guest speaker today is Malo Sergent, Global Account Manager of Opsylog. He'll be answering any questions you may have after the presentation, so please leave them in the Q&A section. Here's Carl Jeffrey, founding editor of Digital Ship, to start.
Today, we're going to show you new ways to improve vessel operational efficiency with data, and we're going to share 3 use cases. So one's about monitoring fuel consumption in new ways, one's about mixing data sources to get new insights, and one is about allocating the best vessel to a task. So doing this, perhaps we can identify malfunction of equipment or guidelines not being followed, or vessels using dynamic positioning or drifting when they could have been moored. Might find vessels kept on standby for longer than they should be, or malfunctioning sensors, or that we had a bigger vessel than we needed to do a certain task. So it might sound easy to spot these things from the data, but if we're talking about a company with a large fleet and they want a short list of specific things which could make the biggest difference to fuel consumption, that's a much harder data challenge. And a theme underlying what we're presenting today is that you need maritime expertise to do all this stuff, because you need to work out from the data what the ship was doing or what the ship could have been doing instead. And that's not something any AI is remotely near being able to do today by itself. AI might be able to help people get these insights together with other kinds of data analytics, but that's something a bit different. So our speaker today is Malo Sergent, Global Account Manager with Opsylog and a former business data and solution engineer with the offshore shipping company Bourbon. Opsylog is based in Marseille in France, and they offer a range of services with maritime data integration and management. These use cases are based on real projects in the offshore support vessel or OSV sector, but I think they'll be relevant to all kinds of vessels. OSVs spend about 1/3 of their time in transit and 1/3 in operations and 1/3 idle, so they're different to most other types of ships, but I think the lessons here are useful, whatever ships you're operating. So we're going to have a presentation of about 30 minutes, and then we'll take questions at the end, but you can put them in the Q&A box at any time. And I'd like to invite Malo to start his talk.
Hello, thank you, Carl. Thank you, everybody, for being there. So I will start by sharing my screen, and yeah, perfect. And so today's we're gonna talk about how to improve vessel efficiency with data, but also with human inputs, and we will go through concrete use cases for that. So first, I'm gonna talk about our vision at Opsylog and how monitoring and digitalizing the fleet monitoring is important, and how to do it. And we will illustrate that by different use cases that we already experienced, and it will be very, very I think very educative for you to have these use cases, so that it makes concrete what digitalization and optimization is. And at the end, we will just conclude and summarize what we said. So when talking about monitoring and digitalizing the fleet, we think first about data, but also what is important is a human when it comes to those aspects. So first, from our experience, once again, defining objectives, clear objectives, and define the proper data needed to cover your objective is important. At Opsylog, we collect activities from our reporting software, Streamlog, but also engine running hours, ROB data, and other related informations. To complete this data and having more a full picture of the vessel and environment, it's also important to collect data from sensors like EFMS, the fuel consumption sensors, also vessel positionings with AIS or other mean. Weather data can be also very important to get the context. As a second step, this data needs to be processed through our algorithms in order to be visualized in dashboards, KPIs, alerts. But this is one step. If you want to go further, it's very important to consider the way to use this data. And from our experience, our clients, they have their day-to-day work. They are superintendents, they are taking care of the fleet, and they have not much time to dedicate to data analysis. That's why being in relationship with consultants or account manager is very important. The consultant will analyze the data and will adapt some thresholds of alerting or making specific studies in order to tell to the clients what is really important to know and where to take the decisions. Of course, everything here is coming by discussing with the different parties, Opsylog and the client. So the could be operator, ship owners, in order to understand their specific needs, their specific constraints, and adapt all these consultancy services to their particular needs. I like starting by looking at this OSV operational profile to introduce the topic. This pie chart is quite simple. It represents a typical vessel life, so talking about an HTS or a PSVs. This is historical data we've collected from 7 years of data collection. And you see that during almost 70% of the time, on average, the vessel is in transit or in idle time. So we decided to focus first on where optimization can happen, and this is particularly on those modes that so idle time and transit, that from our experience, you can have really quick wins and you can make optimization. So we developed enhanced algorithms for idle time and transits regarding best practices, regarding how to optimize these operations. For example, for idle time, by studying the reasons of idle time, we can really gain in productivity and limit this idle time to be more productive. Regarding the transits, also, we can study if the transits are well made and if for a PSV, the deck is well utilized. For crew boats, how the crew boats carrying the right number of passengers. And in top of this operational data, which are used on day-to-day basis to make sure that the client's KPIs are met, we also conduct longer studies, deep studies on those modes, like studying the installation of mooring buoy, implementing the shore power connection, and being able to communicate the potential savings for such installation of offshore power or mooring buoys, for instance. This is only an example. So now I'm going to go to the specific use cases, and the first one will be the fuel efficiency. Fuel efficiency is historically what Opsylog started to do, and this is where all our algorithms have proved their capacity to make optimization. So how it works originally, we identify low fuel efficiency score or abnormal behavior in terms of fuel consumption, thanks to all the what I showed before, the data collection, the KPIs, the alerts, which are also specified and customized based on our clients' constraints. And by the discussion of we have with our clients, we can adapt that. So we identify those abnormal behaviors, we analyze them and discuss with the different stakeholders. It can be the ship owner, the operator, the vessel itself, and we are able then to determine potential causes of deviation from the normal behavior, let's say. It can be a best practice which is not applied for any reason that we have just hear about by discussing with the client or vessels. It can be an issue with the hull, which is not clean, for a dry dock which hasn't been done for a long time. but also some breakdown on malfunction on engines or other parts of the vessel. So those informations, when we talk about clients or operators or ship owners having a large fleet, it's not always very easy for them to have the information coming to them, and so based on the data and the KPIs, we are able to tell them, hey, you are losing money because of that, and this is what we are going to see just later with the concrete use cases. And we are able, with our algorithms, with our fuel consumption model, to really put some figures in front of those malfunctions or those best practices not applied. And then it will help them for decision making, because they will have strong arguments to solve those issues. First, a real use case regarding fuel efficiency is the harbor generator utilization. So here we are talking about an anonymized case. Actually, everything here will be anonymized. It is based on what we have experienced, and this is real cases, but you would not see any name of operators, ship owners, vessel, and but it will just give you a great overview what is possible to do. So talking about a PSV operating in Persian Gulf, you can see in the graph the green colors showing 0 main engine utilization in port. So the vessel was using an harbor generator, which is quite small and economic, instead of using their main engines. So they were using it properly in January, February. And suddenly in March, we see the orange color coming, meaning that they were using 1 main engine instead of 0. So they stopped using their harbor generator to use 1 main engine to supply the power for the vessel. So we were immediately alerted of that and started to do our investigation. We talked with the vessel first, with the operator also, and we learned that this harbor generator actually was not working. There was a breakdown on the engine, and they were waiting for spare parts. So we were able to say that in 3 months, the vessel was losing 25 cubics of fuel, meaning that they could have saved 25 cubics of fuel. It represents roughly $25,000 of fuel currently. And we still, every week, reminded to our clients that they were losing this amount of fuel because of the spare part, which was not coming. And still, you see, we are in June 2024. The spare parts are not yet arrived, and they just arrived actually, but they are not installed on the engine, so the harbor generator cannot be used. And there will be really some. It is very important to put some cost figures in front of that, and it speeds up the process of sending the spare parts to the vessel, because if not, it would have stayed like that for months, and nobody would have take seriously this issue on a small engine. It could have stayed like that for a long time. It's not. It could be seen as not a priority for some of them, because they don't have the metrics and see the fuel that they could save if the harbor generator was used. So this is a good example of how having the right alerts and KPIs with the data combined with discussions and expertise can bring efficiency and optimization. Another one here is about mooring buoy utilization. We are talking about an HTS, which is operated in West Africa and doing a lot of standby because they are mainly here for towing operation, and the rest of the time when there are no towing operations are in standby. You see in the graph at the left part that they are spending around 300 hours per month in standby. So it represents almost 50% of their time in standby at sea, so close to the installations. At the beginning of the period that is displayed here, they were in drifting mode during the standby. And you can see in black the fuel consumption during the standby periods. There was on the field a mooring buoy, which was installed but not used at all. And when we started to do what we call a fuel challenge with the client, we asked, do you have mooring buoy at the vicinity of the installation? And they started to ask questions to the location, the offshore locations, and finally we came at the point that we realized there was a mooring buoy not used, and we asked the vessel to use it during their standby period. So you see in May, June, and July, the green color showing that vessels are doing their standby at buoy, and the fuel consumption in standby really decreased, and where we were able to save a lot of fuel thanks to that. So thanks to a real collaboration between the vessels, the clients, the offshore sites, and Opsylog. And every week we were sending some reports to the client saying how much is saved thanks to the fact that the vessel is using buoy in standby. But in July, we were suddenly alerted that the standby were not made anymore at buoy, but back to drifting mode. We had the vessel Y, and finally learned that there was a defect on the mooring line, and for 2 months the vessel was not able to use it. And here, when talking about a powerful AHTS who is using 2 main engines in drifting mode, whereas they could only use one at buoy and minimize engine power, we are really talking about big figures and talking about $50,000 of extra consumption in a month just for this practice. So it's really a lot, and we kept showing that the fuel lost every week, and be sure that after that the mooring buoy was repaired very quickly compared that how it could have been if we didn't monitor it continuously. And this means that even putting in place some best practice is good, but monitoring the application of the best practice every week, every day is very important, because you can have, and we see that when we stop monitoring it, the best practice cannot be applied at 100% anymore, and because the crew is changing, the people stop to being so focused on fuel efficiency, and even the offshore installation, they prefer having the vessel ready for operation as soon as possible. So they stop asking the vessel to be at buoy. So we really need to put a constraint on that and having a continuous monitoring on this practice. So now from 2021, the mooring buoy is repaired and working well, and this vessel is using it every time and saving a lot of money and fuel, and of course CO2 emissions, which is the most important part. I would jump to another use case, which is a bit at a higher view than what we've seen before. We were talking about real operational KPIs and use cases. Here we are talking about people who are taking strategic decisions on their fleet composition and how the data can help them to make those decisions. So we are talking with an operator in West Africa again, who has a fleet of 5 crew boats, which are used to take passengers from the port to the offshore installations. Those crew boats have a passenger capacity, of course, and that is registered in our system. Thanks to our data, we know how many people are embarking and disembarking from the crew boats every day, and where they go, from at which location, from what is a departure port. And we created dashboards showing the pax occupancy rate of the crew boats, a bit as it is done in the airplane to see to calculate, for instance, the CO2 emission per seat. we have measured the pax occupancy rate of the crew boats during the different transits. And for a year, as you can see in the graph here, we see that the vessel were used only at maximum 74% of their capacity, and on an average about 60% of their capacity, meaning that they have very big crew boats and they are not using their the pax capacities at their full capacities. So when they talk about and think about renewing their fleet, they can think about having smaller vessels, smaller crew boats that will have less consumptions, that will cost less in terms of day rate, and those dashboards are very useful for that. And when it comes to fleet optimization. So here we are talking about people making the different tender for fleet renewal, and the discussion between those persons and us makes those dashboards possible. On the same topic, we've developed a use case and a specific study with a client in North Sea who was hiring a vessel to do mainly flotel activities, but also some DP operation. They were hiring a big vessel, which was very powerful and doing like something like 80% of their time flotel operations. So they had people sleeping on board for the night, and during the day they were working at the different offshore installations of the field. So as a barge accommodation, we estimated that they could replace this vessel, which is big and powerful once again, by another one more efficient in DP with the same passenger capacities, but smaller engines and really much more efficient. So we made those recommendations, and the fuel savings in for a year or 4 months was very, very important, and we were able to put some figures in front of a vessel which is not used for their full potential. So it was also based on one request that we had from the client, and for sure we can replicate those kind of analysis for other use cases. We have the PSVs, for instance, how they use the fully for the deck and underdeck deck and underdeck capacities. Maybe you can have smaller vessels or maybe bigger vessels if they are always filled at 100%, or if you have 2 vessels, maybe they could be only 1 but bigger. All the data are available. We know the ways to transform the data, to change the different KPIs, and in order to do the most relevant analysis. And of course, it comes by discussing with the client to know their operational constraints, to be really close to what they expect, and not just having theoretical studies which are very far from the reality. The third use case is about using different data sources to get more added value in the data, and also how our clients could be, so once again, ship owners or operators, can find the right level of information in this ocean of data. So various data can be available at Opsylog. For instance, we have the vessel activities and engine running hours coming from our software of reporting, our digitalized logbook Streamlog. We also collect, as I said before, EFMS data. So you have the fuel consumption coming from sensors, AIS position, weather information, and all this data mixed through our in-house algorithms and fuel consumption estimations our great added value to put some insights to the data collected. But having dashboards, KPIs is one thing, but clients have very limited time to dedicate to this data analysis. So they need people to study it and Opsylog to highlight them on what needs to be highlighted. So for instance, we can, one added value can be, do I have a high data quality for the data that I'm collecting? So people are operators, ship owners, they are buying some services, they are buying EFMS positions, AAS positions, they are buying also the Streamlog software. And we ensure by having different data sources that those data have a good quality. One example, for instance, as you can see in the illustration, is how do we make sure that reported consumption and consumption coming from sensors are good. This is by having different sources of data. At Opsylog, we have this reported fuel consumption coming from the digitalized logbook. We have the fuel sensors, and we have the algorithms, which is estimated the fuel consumption based on vessel activities. 3 sources of data is very useful to see if one of them is not working properly. For instance, a reported consumption very high and higher than what we expect, and also higher than what the fuel sensors is giving, is suspicious. Why the vessel is reporting such high consumption, whereas the 2 other sources are showing something different. Another example on this topic is if you see that the reported consumption from the vessel is in line with what is expected from the vessel activities, but not in line with EFMS positions, EFMS consumption, sorry. For instance, high EFMS consumption, so the sensors is giving very high values. It can be a malfunction in the sensors. In that case, Opsylog is highlighting that, is investigating with the data providers, trying to find what is going wrong. And most of the time, there is an issue with the sensor which need to be repaired. And without that, most of the time, our clients won't know that because they are not looking at the raw data and they have no time to look at that to ensure that their data is good quality. So data quality is very important, and we help them for that. I have other example in mind. For example, studying the weather data and combining them with vessel activities can be very important. We had a client which had different vessels equipped with gangways to do passenger transfers. We helped them with weather data, with a swell, to benchmark the different vessels operations and to know at which limit of swell the vessel could operate. And by benchmarking the vessels, we saw that some vessels were stopping to do the passenger transfers had, for example, 1 meter of swell, whereas other one managed to go up to 1.5. And by aligning the best practice of the best vessel, for instance, we were able to even keeping safety as a priority, of course, but to have optimized practices in terms of gangway utilization during passenger transfers. So we could talk about other use cases about that because we have plenty of them, but of course we remain available to give more details on that. And I think now we made quite an exhaustive list of use case and description, and it's time to conclude on that and to say that as we have seen, collaboration and understanding between the different parties, vessel owner, operator, and Opsylog consultant and account manager, is very important to get successful projects realized. Implementation of mooring buoy or monitoring the best practice, changing the behaviors of the vessel. And so having expertise and having people looking at the data is key. and making key stakeholders speaking between each other in front of the data is even more important. And giving fleet feasibility and benchmarking the vessels between each other on their best practice is also very important to take long-term project and having long-term strategies. Thanks all for hearing that, and now I think we will have some questions and some discussions for a few minutes.
Yeah, well, thank you very much, Malo. So if you'd like to stop screen sharing, there's already 5 questions on here. So I guess we can, well, just for me to understand, are you actually getting involved with the ship operations on board at all, or are you purely, I mean, you're not putting any technology on the ships, as I understand it, or are you? Or
So at Opsylog, we have a reporting software, which is a digitalized logbook where all activities are captured. It can be vessel operations, engine running hours, the ROB, so the list of the different products on board, and also other related information, like it can be HSE, crew information, which are for other use cases and fuel consumption, but useful for our clients who want to digitalize all their fleet monitoring. And everything is in cloud-based and an online platform with a lot of data quality checks, for example, preventing from captain mistakes or having some minimum, maximum threshold to avoid what an Excel sheet cannot avoid. So this is what we do. But we don't install any hardware in the vessel.
okay,
But we can
okay,
interface with people who have the hardware and the data.
yeah. So it's expertise, service, data, and expertise. Yeah, that's very interesting because it makes you very unique with all the other companies we have. You know, everybody else talks about stuff on the bridge and giving crew more things to do. There was a press release yesterday from the International Seafarers Welfare and Assistance Network about how crew are getting exhausted by all these demands from decarbonisation. And it struck me you're not making any demands on crew at all, apart from just to say maybe you should be doing this differently. And it's very different.
Yeah, but it's we try to have as much as possible constructive relationship with the vessel, to just not to put pressure on them, but to hear what they have to say. And most of the time, their feedback are very professional, so it helps us improving our algorithms, our recommendation, and we hear their constraints. Most of the time, for instance, this is not the crew. If a vessel is not following the best practice, it is not only their fault, or it's an ecosystem with the offshore installations, the people on shore which are giving the orders. So we exchange between each other to have the most optimized practices.
Oh, very good. Well, you've got 5 very interesting questions, and Okechi looks like he's about to add a second question, but you haven't entered it yet, Okechi, if you want to put that in. But the first question is for Okechi Okora, who's with a chief mate with Bourbon, based in the UK, but might be working in Nigeria. But he's asking what happens if data is falsified, data input in the stream log. How do you ensure data are accurate? I mean, you put in a point about the 3 different ways to get fuel data. I didn't know about why people would falsify them.
Yeah, so if we talk about fuel, but it can be other data, and we are working in countries where there is a important concern about abnormal consumption and possible fuel traffic. So this is one of our key use cases. Actually, we have algorithms, we have different sources of fuel consumption, data quality checks also, that can lead to alerts and investigation to know if the vessel fuel consumption is falsified, as you said. For instance, for the fuel consumption, we collect fuel sensors from other providers that we can compare to our own sources and see who is right, and understand if what is reported is relevant based on our benchmark. We have a vessel design approach with a unique model per design. If a vessel is reporting much more than what for their activities than what we expect, because we know sister ships in the same country or in another country which are reporting less for such activity, it brings our attention and we start investigation. Sometimes it's coming from a malfunction on board, for example, the hull which is not clean, but sometimes it can be something else. And when the vessel feels that they are monitored and we have the data to understand to have the full picture of the vessel activities, the consumption can go down again and be back to what is expected or not. But actually, we can make a real recommendation to the operator to say this is really abnormal or not. And yeah, I think it's answer to the question.
Yeah, it's good you have real people looking at this, not machines, I guess, because
yeah, data quality anyway is very central in our business model, and we have a team of data quality experts which are looking at the data, contacting the vessel if needed, or launching some actions to improve this data quality.
Oh, very good. Okay, so the second question, you answered this, but perhaps you give more. So this is from Edgar Bourbon, who's from technical superintendent with Bourbon in Marseille. You might know each other, but he's asking, do you install your own sensors or are you using those already installed on board? I think you
So
use
yeah,
one.
we don't install sensors, but we interface with people who do it. But our solution is working without sensors. It's really if you have a vessel which is not equipped with sensors or with sensors with data which are not coming back to the shore, we can, with our system, with our digitalized logbook, we can already do 90% of the job. And having sensors, fuel sensors, is a plus, but not mandatory at all to run the service, because we will have the vessel activities, the vessel consumption, the fuel consumption model, which is already quite an important amount of data.
Oh, very good. Timofey Belorusov, who's with Ocean Lee in Armenia, he's asking, how do you collect data from sensors? Does it go automatically, continuously, or do crew send the files periodically?
Mm-hmm. So when we collect data from sensors, we have partnerships with companies who have these sensors, and we have API in place to receive this data automatically without intervention of the crew to send files.
Okay, very good. So it's a bit of a longer question now. So this is Stavros Michaelides from Ulysses in Athens. Assuming all data coming from the sensors is reliable, the decision-making process has a collaboration between seafarers and the consultant to discover the root cause of the alerted situation. Is this correct? Will also the shore office, I don't know about the seafarers, get involved?
Yeah. Mm-hmm. Just at the beginning of the sentence is assuming that all data coming from sensors are reliable, but also not only from sensors, and it can be also from our systems, our Streamlog reporting. So assuming that all data is correct and reliable, yeah, the decision making is also coming from collaboration phase, and this is what I said previously. This is the most important. We are not going to give some recommendation which are not applicable. We will, or if they are not applicable because there are some constraints that we've missed because we don't have the full picture, we discuss with seafarer, we discuss with operators, ship owners, to have the real and possible configuration of best practices, and our system is made to adapt to the different situations. And we try to we have in our companies people who are doing the recommendations. They know the operations, so they know how to discuss with seafarers, and they understand their feedback to adapt all that.
Oh, very good. So we're going to London now. Jonathan Lane is head of sustainability with RightShip. He's asking about how do you manage the sensitivity of obtaining fuel data, particularly with ship owners? And I guess you're a client, so they trust you, I suppose. It's a simple answer, is it? Or so you're a supplier, they're the client. Yeah.
So fuel consumption data is one of the data which historically is filled in all the Noon reports, Excel sheets reports. So people at sea on board are used to report it. So there is no real issues on that. So people report their daily consumption in our software. and it can be combined by sensors, by EFMS data, and also with our model, we have the third source of fuel consumption data. But generally, there are no blocking point in communicating the fuel consumption data.
Yeah, they're not sharing it publicly, are they? They're sharing it with a private supplier, and you've got contracts, I expect. I mean, it's the same with the crew data, that they're giving you a lot of confidential information. And obviously, you've got good relationships with the clients. Yeah.
Yeah.
So back to Ketchy, I didn't actually understand 2DG. I don't know.
Yeah, 2DG is two diesel generator, two engines.
2 diesel.
So so when vessel is transiting through the channel, which requires the use of 2DGs. Of course, sometimes it can. We have some cases where the best practice, in that case, we can assume that the best practice is to use 1DG, and in the channel, it requires to use two for safety reasons, because there is you need to have a second engine in case of failure, for example. We, of course, and in all our recommendation, say that safety must prevail, and we are not asking the vessel to be at risk. So we make the difference between the transit in open sea and the channel passage, or in some countries there are some constraints when vessels are navigating inside the field limit. Even if it's out from 500 meter zone, it can be in the field limit. They have to keep 2DGs. So we adapt that in order to give a relevant recommendation and fuel potential savings which are relevant.
Are all Opsylog staff doing this sort of work? Are they all ex-seafarers? Or I don't know if you're an ex-seafarer, but I see you worked in Bourbon.
I'm not, but I'm a marine engineer, and I've worked for 10 years in this sector. So now, even if I'm not a seafarer, I understand the constraints, and I've worked with a lot of seafarers, and in Opsylog,
you know what a generator is, and
yeah, exactly,
So that's why you can flag if you should be using 2 generators or not. That's
yeah, sure.
Oh, there we go. So next, Daryl C is with IO3 in Singapore. How often is data synchronized to clouds? I think we had this already, but
it's synchronized actually in almost real time. When vessels are inputting data, we can collect the new data which are coming. But our studies most of the time are made on let's say 24 basis. We are not giving a real-time recommendation to the vessel. We are studying the past operations of the past day or past week to determine some tendencies, some good or bad practices, and address them to the different stakeholders. But the data, when there are new data, they are coming in our database for analysis in almost real time, because we have a cloud-based platform which is always connected to our database, and every few hours there is a new data flows coming to our centralized database.
Well, very good. You'll have to help me with this next question. So Yavuz Aydin is a deck superintendent. FO/DO. He says, please clarify, you have all the supplier datas which locate a certain place. Is that FO?
So,
do you know?
I believe it is fuel oil and diesel oil.
There we go. Yeah.
We know at which place the bunker occurred, so we have the locations. And when vessels are reporting their bunkering operations, they have to report the sulfur content, so we can know the quality of the fuel, the density. And now, this is very new, they can also put in the bunkering delivery note as an attachment of the bunkering operation, so that we can study it. And if there is a specific use case on comparing, benchmarking the bunkering location to see the quality of the fuel, it's totally possible. And we would be more than welcome to develop specific use case on that. We do compare locations performances for other use cases. For example, I'm thinking about monitoring the flow rate at the location, so the fuel or other product flow rate, to see at some places there are they spend more time to deliver the product. This is another use case of how we can compare locations between each other.
Yeah, that's very interesting. So Georgiana Nastasia, I'm not sure where she's from. Do you offer online or remote support 24/7? And she's also put in a nasty question. I don't know if this is a competitor here. Do you have any challenges with customers you'd like to share with us? I mean, normally companies wouldn't want to answer that question.
Challenges.
Yeah,
after,
feel free to say no. You don't want to answer that.
No. But, challenges is always a part of the life also, because we have challenges with to adapt our solution with to the reality. To when we have feedbacks from the vessel, it's always different because we face new situations that we didn't have when we work in a new country, for example. But all these challenges are actually a good way to improve, and then to be ready to answer in the future to the same need. And we see actually that most of the time the needs are coming back. The constraints, the challenges we have are coming back in other situations. So we learn, and we have all this knowledge base, which is learning for us, and we can have the same reaction after when we face the same challenges that we encountered before. So I would say there challenges is part of the life, and this is why this is exciting, and we don't have always the same the same thing, the same use case coming. And does Opsylog offer online or remote support? So we have remote support. Yes, our support team is there during the open day, so not 24/7, but very reactive from 8 o'clock to 6 p.m. And by phone, by email, you can contact them. They will also contact the vessel for data quality issues, for if the vessel is not reporting, for instance. This is very important and key to have that.
Yeah. Are there any restrictions on moving the data around? I know lots of countries say you can't move sensitive oil and gas data actually out of the country, but I don't know if this applies to OSV data, does it?
The other one is about digital logbook, I think.
Daryl C from Singapore. Yeah, is it type approved by class?
So we are developing this digital logbook. We have record book already, which are approved by class. We have the garbage record book and engine record book, which are approved, and the rest will come. This is an important project to have it approved by class. At least what we do, even if the bridge logbook, for example, still remain available and mandatory on board, and is not still approved by Opsylog 1 is not still approved, we suppress a lot of workload on board, because they are used to fill a lot of Excel sheets every day at even the same information. We see that with all our clients, and when we have a new client and we start to collect Excel sheets from them, they are asking vessel activities to different persons. They fill 3 Excel sheets with the same information, and we centralize that. They fill the data once in a Streamlog, and then we populate the information to the different persons at the format they want. We create a new report to the person who were used to ask it to the vessel. And like that, we have a single interface to fill this information.
Oh, that's very good. Oh, I think it's an amazing story. That we don't have any more questions on the board there, but oh, sorry, one. Well, I was just wondering about the scale. Could this be 10 times bigger as a company? I mean, I guess you'd have to recruit seafarer experts, but there's a lot of people who understand shipping in the world, aren't there? That I mean, could you imagine doing this for a company like Maersk or something like this? I guess you could.
So having physical hardware installed on vessel.
Oh, go back to the questions.
Yeah. Sorry. Yeah, I thought you were talking about the question.
Oh no, well, I was just wondering how big this business could be. That could you imagine? I mean, you're already supporting quite a lot of vessels already, isn't it? Hundreds of vessels. So, yeah. Okechi is asking, would you put more physical hardware on the vessel in future to help in obtaining more accurate data? Well, I guess you work with a company
So hardware for the moment is not installing hardware is not our business model, but more to interface with people who have the hardware and the data and to collect the data. We are a data integrator in order to create values with it and cross and combine the different data sources. So we have currently some initiatives to collect a lot of data from the PMS and having very big data, a lot of data entries, and we have data scientists who are experiencing that, which data are relevant, what are the use cases that we can have with this data. So in the future, for sure, we will collect more and more data coming from hardware, because this is the direction where we all go, having more connected vessels. And but we will have to keep in mind really to use the data which are useful and not just collect data for the point of collecting data and doing nothing with it. We are very focused on, we are result oriented. Our objective is to transform the data into real actions. So for that, we need to get use cases which are identified and not collect thousands of type of data for which we don't do anything. Just saying, oh, we have a big data, we have a lot of data sources, data entries. If you don't do anything with it, it is useless.
Yeah, no, that's very good. Yeah. Oh, another question. Well, doing Felix Francis. Oh, okay, so wants to do a
Sure.
business collaboration, so perhaps that's something to take offline. But yeah, so,
yeah, of course, you can contact us. I believe by email. There is a contact at the end of the presentation, or we can
arrange,
connect together. Yeah,
yeah.
very interesting.
Yeah, very good.
Yeah.
So yeah, on the scale question, I mean, could this business be 10 times bigger if you're going to serve enormous companies going around the world? I guess it's exactly the same business model if it's a big tanker company.
Yeah, sure. Well, our solutions were initially developed for oil and gas sector, offshore support vessels. Our use cases also, but it can be replicated to other sectors. It will be different. The recommendation will be different. The vessels are different. They are using different fuels or different type of energy. But we can replicate that in other sectors for sure.
Yeah, I mean, there's still same issues with diesel generators in any ship anywhere, I think, isn't it?
Yeah. But it will be different for example, ocean-going vessels won't be interested in having those small. They don't have the versatility of operations that all OSV have. They will be more interested in weather routing, in studying the impact of the consumption on very big trips. Whereas for PSV, it's very small trips with standby operation, standby transit, a lot of changes, and sure, we can replicate and change our best practices. It is made for that, actually.
Yeah, I mean, it's still basically about generators and speeds and standby time. I guess all ships have the same issues when it comes to fuel consumption. Perhaps a bit more about the routing for bigger ships, but I guess that's also. I mean, it's also about looking at things and trying to work out where they could be doing things better and having expert people doing it. And yeah, it seems to me this is the way this stuff is going. The more and taking the load off the seafarers, I think that's going to be more and more important. Judging from this ISWAN survey, that a lot of seafarers already feeling stressed and under pressure. They think they're going to be.
Yeah.
And this takes the work away from seafarers by the sound of it, doesn't it? Or you just say, maybe you should have told us you didn't have a spare part, perhaps. Do you realise that spare part cost $20,000 of fuel? Yeah. Oh, that's fantastic. Well, we're coming to the end of the time now, so I mean, there's no more questions. I don't know if there's any last words you'd like to give people, then we can finish if you'd like.
On my side, you mean some last word?
Yeah.
Okay. Yeah, but thanks everybody for attending to this webinar and presentation, and I hope that that you have understood how it works, and if you, for example, is a ship owner intending to have some digitalization project, really think about use cases behind that, not only digitalization for the sake of digitalizing the fleet and being modern, just use cases, how we can improve your operation, the fuel consumption and the environment, and yeah, that's it.
Yeah, that's great. Well, thank you very much. Well, we've finished there. Thank you very much, Malo, and I shall pass back to Farah for the closing words. Cheers.
Thank you. Yeah. Thank you very much.
Thanks to our guest speaker, Malo Sergent, and to all our viewers for joining us today. If you have any more questions to ask, Malo's contact details, along with a recording of this webinar, will be on its way to you soon. Have a great day.
Bye-bye.
Bye.